Science is Earth smart? We came up with a way to measure the intelligence of entire planets. Things aren't looking great for ours. By Adam Frank, Sarah Walker, and David Grinspoon, February 19, 2022. Share. Almost a century ago, the revolutionary idea of the biosphere gained a foothold in science. Defined as the collective activity of all life on Earth, the tapestry of actions of every microbe, plant, and animal, the biosphere had profound implications for our understanding of planetary evolution. The concept posits that life acts as a potent force shaping how the planet changes over time, on par with other geological systems like the atmosphere, hydrosphere, water, cryosphere, ice, and lithosphere, land. Essentially, life has the capacity to hijack Earth's evolution and, perhaps, steer its fate. The biosphere tells us that once life appears in a world, that world can take on a life of its own. This idea first came as a shock to many researchers. Over the years, however, it has become central to Earth science, deeply influencing how we see life interacting with our planet, and our ideas about what life might do to other planets in the universe. As our understanding of the biosphere's influence has deepened, it has also pointed to a provocative question, one much less explored. If a planet with life has a life of its own, can it also have a mind of its own? Granted, any notion of a planetary mind might seem like New Age woo. Intelligence tends to be conceived of as something that happens in individual heads, and usually those heads sit on the shoulders of animals like humans. But over the past 2 decades, evidence for collective, distributed intelligence has appeared in a wide array of creatures and a staggering variety of scales, often in forms utterly different from our usual conception of smart. Bees and other eusocial insects, for instance, clearly show evidence of collective intelligence. A single bee holds only a small amount of information about the world, but its colony as a whole knows and responds to the environment. Or consider trees' root systems, which connect to one another through underground strands of fungus, creating a kind of forest nervous system. Such fungal networks allow forests stretching hundreds of miles to recognize and respond to changing conditions. In this way, some have posited a kind of green mind distributed across space and time. Going so far as to account for the collective intelligence of all life on the planet is, admittedly, an audacious use of the concept. But over the past couple of years, we, the authors of this article, decided to give it a shot. Our work has been a thought experiment, one that plays with ideas that science understands but extends them to confront a stark reality: humanity stands at a most precipitous moment in both our and our planet's evolution. We have discovered that the universe is teeming with worlds, many of which might host life and even intelligence. At the same time, our own world is in peril, caught in a climate crisis brought on by our supposed advancement as a civilization. Even though Earth might be full of intelligent life, at this point in its cosmic history, it certainly doesn't seem very smart. Making sense of how a planet's intelligence might be defined and understood helps shine a little light on humanity's future on this planet, or lack thereof. Let's start by defining planetary intelligence in terms of cognition, the capacity to know something about what's happening and act on that knowledge. Because science has already shown that certain living systems respond collectively to their environment, we consider planetary intelligence to be life's collective response to changes in the state of the entire planet. We're not interested in just any kind of response. What matters is when collective smarts are put to work toward life's most essential collective purpose: survival. As we conceive of it, planetary intelligence is measured by the capacity of life on a planet to sustain itself in perpetuity. To be clear, cognition is not consciousness. We don't imagine some kind of planetary superbeing making self-aware decisions for the world about which species it likes best and which baseball team to rain out next Tuesday. Rather, the more rudimentary form of responsiveness that we have in mind can be traced throughout all branches of life on Earth, far beyond humans and other creatures that exhibit self-awareness. More than reproduction, some scholars now see the ability of organisms to self-produce and self-maintain in changing conditions as the hallmark of life. Take the membrane of a cell, which must continually be rebuilt through actions that include the membrane or the cell dies. The membrane is both a process and a product made by the cell that allows the cell to go on living, which, in turn, means creating more processes and products that maintain the membrane. It's a strange chicken and egg cycle that makes life possible. In this way, planetary intelligence is what scientists call a complex system. It's a dense web of feedback loops and interactions that emerges as a higher-level phenomenon from the activity of zillions of lower-level players, like microbes. The collective result, for planets that actually achieve intelligence, is that life doesn't doom itself over time. This all might sound like a leap, but notions about planetary cognition extend back to the ideas that first gave birth to the biosphere concept. When the Russian geophysicist Vladimir Vernadsky first began emphasizing the term biosphere in 1926, he saw it as a force that collected and redistributed solar energy. By hijacking the Earth's basic energy flow, life took the planet's evolution in entirely new directions that would be impossible on a dead world. Vernadsky thought life had always had some degree of cognitive activity, even before humans showed up, which he called cultural biogeochemical energy. Decades later, another landmark ecological hypothesis upped the ante. Gaia theory, the still contested idea that helped give rise to modern Earth science, proposed that life perpetuates itself by shaping the planetary systems to keep Earth habitable. The idea was introduced by James Lovelock and Lynn Margulis in the late 1970s, and Margulis in particular took an expansive view of collective intelligence. Even on worlds that had only networks of microbes affecting non-living planetary systems, some form of planetary intelligence was a given for her. Margulis's revolutionary studies on microbial life convinced her that their planetary-scale collective activity was smart, that is, it kept the planet habitable, in ways Vernadsky had not imagined. Once an intelligent species does appear, Vernadsky, Lovelock, and Margulis all saw the possibility of new rules between life and the planet. Vernadsky referred to the new domain arising from intelligent life as a noosphere. Noo is Greek for reason. The noosphere emerged as fruits of thinking blanketed the planet in technology, which then drove powerful changes in Earth's behavior. In this way, Vernadsky anticipated phenomena such as the Internet and climate change. Unfortunately, he failed to imagine how intelligent life's fruits of thinking might rot. The usefulness of defining planetary intelligence in terms of survival is that it offers a way to evaluate the progress of life on any given planet toward that goal. It forces us to ask, what has to happen, in terms of evolution, on planets that develop robust biospheres and sustainable technological civilizations in order for life on these planets to persist? While we're limited so far to a sample size of only one known life-sustaining planet in the universe, Earth nevertheless seems like it might be instructive. In a new paper that lays out our theory of planetary intelligence in detail, we propose that life on a planet can collectively evolve through 4 distinct states, each with different levels of planetary-scale intelligence. Each of these phases directs the fate of the planet in different ways. Earth has made it through 3, but we haven't reached the 4th stage yet. And that's what's getting us into trouble. First is what we call the immature biosphere. Life appeared on Earth at least 3.5 billion years ago, 1 billion years after the planet itself formed. During this early period, the Archean Eon, life was not yet a major planetary player. Researchers estimate that the Archean biosphere was less than 5% as productive, in terms of harnessing energy, as today. With such low energetic capacities, life couldn't yet exert forces on the atmosphere, hydrosphere, or other planetary systems to shape their evolution. There was life, but there were few global feedback loops and hence no emergence of intelligence. Next, the mature biosphere. Over the next billion or so years, life on Earth spread and evolved. It created denser webs of interaction and new capacities. The development of a novel kind of photosynthesis, one that drew in water and spit out oxygen, would prove to be a game and planet changer. Saturating everything with oxygen, life rewired the planet. Eventually it led to the emergence of the ozone layer, for instance, which shielded the planet from the sun's dangerous UV radiation, the sunburning kind, and allowed life to settle the continents. This thick tangle of feedback loops between living and non-living components comprised a network that could be said to hold and respond to information in a meaningful way. Earth, in other words, started to become smart. It's crucial to see that by our metric, a planet does not need to be home to any intelligent, technologically capable species to exhibit some level of collective intelligence. In Earth's mature biosphere phase, an early form of planetary intelligence that worked toward the entire system's habitable self-maintenance emerged long before humans did. Just as important, an intelligent, technologically capable species does not necessarily make a planet intelligent. That brings us to our remaining two states, the immature technosphere and the immature technosphere. The term technosphere comes from the researcher Peter Haff, who defines it as the interlinked set of communication, transportation, bureaucratic and other systems that act to metabolize energy resources. From trucks on highways carrying manufactured goods to packets of information riding the ether of wireless internet connections, the technosphere is a newer example of a complex system in our model. It emerged from the biosphere, via us, to become its own planetary power. In its scale and complexity, the technosphere is almost as awesome to contemplate as the biosphere. But everything rides on that almost. That's because our technosphere is still immature. The biosphere became mature when it integrated into the other planetary systems in such a way that, at the very least, it didn't actively degrade the Earth's habitability. But our current version of the technosphere has it all backwards. It's not integrated into the other Earth systems. It simply draws matter and energy from them. Our technosphere is, in the long run, working against itself. It's formally stupid. It leaves the entire planet unguided, careening into new and uncharted territory. This is not self-maintenance and self-production. It is not a state of planetary intelligence. What Earth needs is a mature technosphere. This would be a technosphere rooted in the biosphere, which itself is rooted in the other planetary systems, a technosphere that self-maintains the entire Earth system. Only this would make Earth fully intelligent, because as far as we can tell, it's what has to happen now for our kind of civilization to sustain itself on the planet in the long term. The concept of planetary intelligence offers no instant solution to our climate woes, nor does it provide a detailed map of how to escape them. But it does, at least, put our own delicate moment into its proper place in the Earth's long evolution, and begin to model a goal. In going from an immature to a mature biosphere and then an immature to a mature technosphere, we can see how the planet must scaffold layers of complexity and weave the living and non-living domains together into an ever more powerful whole. And the emergence of new kinds of integrated planetary intelligence would be a hallmark of the transition we are trying to manage now. It might also be a transition that any civilization anywhere in the galaxy must navigate if it wants to be around for a long time. This is where planetary intelligence touches on the field of technosignatures, the search for evidence of technological civilizations other than our own, also called the search for extraterrestrial intelligence, or SETI. Recent studies have shown that the first alien civilization we detect, if that happens, would likely be much older than our own. Because long-lived civilizations must be sustainable ones, understanding planetary intelligence might help point the way to knowing what kind of technosignatures we should be looking for, as well as how to look for them. How Earth, or any planet, might achieve such a level of self-sustaining harmony is the next task in understanding planetary intelligence. The moves from immature to mature biosphere and then on to a mature technosphere aren't predestined steps on an inevitable evolutionary journey. Life on a planet could fail to develop in any imaginable direction. An immature biosphere might be unable to create dense enough feedback loops to rein in other planetary changes that render the world uninhabitable. And humanity, as we march down the path to global climate catastrophe, will not necessarily save ourselves simply by virtue of our own continued technological innovations. After all, such innovations are what got us into this mess in the first place. At the same time, humans at least are intelligent enough to comprehend the calamitous direction we're headed in. That level of self-awareness opens some possibility of choice. It might appear that a technological species can establish planetary intelligence only through some kind of top-down centralized control, like a single authoritarian world government. That is a mistaken notion, however. By integrating feedback loops on many levels of organization, planetary intelligence may emerge from a kind of democracy of influences that flow upward and downward through the system's hierarchies. In 1987, humanity managed to ban the dangerous chemicals that were destroying the ozone layer without authoritarian rule. That was, perhaps, an early example of what the new version of planetary intelligence could look like, a first glimmer of our technosphere becoming smart by becoming wise.